Welcome to Electric Vehicle Television. I am Marion Rickard. Actually, they call me Jack.
I'll call him Jack, that's right.
I'm Jack Rickard. This is my compadre and consigliere, El Breno Noto.
Hey, it must be Friday.
It's feeling like Friday.
Yeah, it's
Which
starting
Friday
to work.
is it?
Yeah, this is the Friday, the 9th of December. 9th
We're
of
heading
December.
for the winter solstice. What are you bringing, big guy?
Well, I didn't bring it. It arrived in
It just arrived in the mail.
It arrived in a mail, and it looks like tequila.
Why does this stuff just come to us?
You know, I don't know, but I hope it doesn't stop.
They don't think I'm drinking enough.
That's right.
I can tell.
Oh, look at that.
That's a pretty bottle.
That's some Herradura Añejo, which is
Means aged.
aged. Yes.
100% agave.
Look, we got to look at that.
With official-looking seals.
Official-looking seals all over from the Federales, the Mexican government.
That's good for me. My wife likes this. I kind of like it because she likes tequila. Tequila likes her. And the tequila and the clothes don't like each other. They can come right off. Oh, that's got a good bouquet for tequila. I don't even feel like going and hugging a toilet or anything.
No, and I'm thinking that he may have bought this in Mexico because this has the Mexican national liquor tax.
Ooh, very
seal on it
too.
Yeah, and I like Herradura. It's here in the United States, like what, $40 a fifth?
I've
or
never
something?
had it before.
Yeah, it's really good.
George Hamstra sent me some very good tequila, and I made some sway with that with the Mrs. Rickard. But I think I might be able to do some damage with this one too.
This is actually really good.
Most of the tequilas, of course, are unaged white spirits, or what we call, among the makers, raw dog. I like aged spirits in the barrel. And Añejo is the closest they have.
Yeah, this is...
That's actually pretty good.
Got a nice note. It's smooth. Got a very nice nose. Wow.
I can do that.
We are.
Who sent that?
That was Mark Weisheimer.
Mark Weisheimer, our friend from AP.
Yeah, AP. Yeah. Yep, he sent it out. Yeah. He did a lot of work at the show for us, man. Helped us with our internet connection.
He did.
He did a lot of stuff. Mark's a great guy. And since tequila, his stock just went up. I say we buy Mark. Buy some Mark.
We'll buy stock in Mark.
That's right.
At least an option on it.
That's right. We'll just see what happens. That's right.
Take a flyer on it. Thank you,
thank you
Mr.
very much.
Weisheimer. If you all will recall, Mark is the one that took us off of the Vicor bricks that I was kind of living basic with, and showed us how to just plug in their whole mega pack.
The whole pack, yeah.
It seemed a little big to me at first, but I got used to the idea real quick.
Yeah.
And they work quite well. That's Mark Weisheimer, who's kind of a regular thing. What else have you got?
Well, did a little news this week. We've been working on the swallowable. Let's see what happens. Let's see what people have just found out there that we've fallen over. I guess California has declared itself the world's EV leader.
Really?
Yeah, they say that there are $487 million in EV-related venture capital investments in the first half of 2011, which they're saying is 70% of the global total. They got a fairly good growth in Silicon Valley and Orange County. 712% since 2006 growth. Blah, blah, blah. Well, ranks first number of total electric and hybrid vehicles. But they're making a claim that they are the, fast becoming the world's advanced car capital.
I believe it, and I'll tell you why. A gentleman named Alex Chadwick was at the Electric Vehicle Conversion Convention this past September, doing a story on Mike Pethel, I think.
Oh, okay, yeah,
That's
right.
He came away and kind of wanted to do a story on us, and I agreed to talk to him one morning, and we spent a couple hours talking. I have no idea what this story is like, but I, some time later, got a request for a release from a woman who worked with him that they were doing a show on Marketplace, which is
It's just a public radio.
Yeah,
PRI,
National Public Radio.
I think it's on PRI, does Marketplace, yeah.
yeah, and so he was going to do this show. I got on Marketplace this morning because they said today was when the show was going to air. I haven't heard it yet.
Okay, so it's going to air today. Oh, good. Okay, I didn't know.
But I looked on the website, and they had these maps for different things. And you could do, like they had one for electricity costs by state, and you put the mouse over each state, and you get what?
Get their rate per
I
kilowatt
happened
hour?
to check the hybrid sales by state, and California was over 100,000 hybrid automobiles per year. Texas was about 10,000. Virginia was about 13,000.
Okay, okay.
Florida was about 13,000. Of course, Missouri was like 900
That's right.
in the state.
We're a brown state, I'm sorry.
Yeah,
we're helping make it
we're
green,
a
though.
brown state. No, a lot of the little states in the hinterlands were 1,000.
Yeah, there's just not a lot.
Where California was 100,000.
That's amazing.
They also have 34 million
Yeah.
registered drivers compared to Missouri's 4 million.
Whatever, yeah, we have here, yeah.
But still, it was a striking number of hybrid sales. California really is ground zero for this electric vehicles and hybrid vehicles and alternative fuel vehicles and so forth. Their governor, Schwarzenegger, previous governor, was very much behind that, in favor of it. And and then of course they set these CAFE standards. And now Obama has set the 54 mile standard for U.S. automakers. That really is the driver behind the OEMs doing the electric.
Right, doing it to get in that.
Now, let me tell you what happened last time. They managed to talk them out of the CAFE standards, and the electric vehicles were literally hauled away as that agreement was reached.
Right, oh yeah. Yep.
So they're all for electric vehicles until they don't need them anymore, and then they
snatch them.
They want them out of there.
Yeah.
And so I'm kind of in favor of these CAFE standards. 54. Why not make it 254?
Well, and California kind of drives all that too, because their what is that? The CARB, the California Air Resources Board, really can set their own, because California's always had its own, and it does really lead the country because of the amount of cars sold there.
What else have you got?
Well, it looks like, and I know it's a really popular vehicle with a lot of our viewers, the Ford Ranger. The last one is rolling off of the assembly line. They're not making that platform anymore.
They're not making any more Ford Rangers.
No, it's gone. Let's see. I guess they make them in St. Paul, Minnesota.
It's worse than that. The Ford F-150,
Yeah.
which is taking over that line of business, not available with a manual transmission.
Oh, see, that makes it tough.
They're all automatic. Did you imagine you would see a day when Ford didn't offer a manual transmission in a pickup truck?
No.
I just can't even imagine.
No, in a truck that could be a work truck.
Right. No, they normally are,
my
but
goodness.
how can you have it without a manual transmission? Where is it going?
Now, they did have a cute little thing here.
The smart...
The smart with the added butt, and you can basically hook up with the smart electric car with a two-wheeled contraption here that looks like the rear end of a smart car that carries a battery pack.
Does this make my ass look big, car?
Yeah.
No, dear, it doesn't.
It doesn't. But yeah, what's the if a
don't ask me how I know.
if a man was in a forest speaking and there's no women to listen, would you still be in trouble?
Would you still be to blame?
That's right, you'd still be to blame.
Would it still be your fault?
That's right, it'd still be your fault.
If man was speaking in a forest and there was no women there to hear, would you still be at fault?
That's right, yes.
Technically, yes.
And we talked about the GM, about the Volt last week, and
the Volt.
Yeah, and I guess there's still more. There's there people have started to file down there and get their money back.
Yes, I've heard there was 23.
Yep.
Who wanted their money back after all. And so this story is kind of coming unglued. Now they're talking about Chevrolet redesigning the battery pack.
Yeah, apparently they're giving them more more vehicles to crash test, and they're not quite sure what it was.
Now they're talking about the coolant crystallizing and being the problem.
Yeah.
I don't believe that.
Yeah, I don't know. Yeah.
I tell you what they're going to find. I save them a lot of time. When it's all said and done, of course it'll be their battery management system that's failing and causing the fires. And the batteries are perfectly good.
Batteries are good.
They're not the batteries I would use with the manganese oxide spinel, but they're going to find that it's an over-engineered battery pack that's causing the batteries
problems
to fail.
Wow.
And it's, once again, the BMS. It's very difficult once you get started doing that to not have a mess of wires and connections and semiconductors that are of unknown real parentage despite their specs, that they will do what the vendor said they would do.
Yeah, who knows?
Is not certain.
Right.
So GM's in kind of a mess. I think they'll persevere because of these CAFE standards.
Yeah.
In 2013, they're supposed to introduce a Spark. Apparently, I laughed last week over the Chevy Cruze getting a hybrid.
Yeah.
It's good. They're talking about doing that, and it's a hybrid different from the Volt.
Okay. But why?
Yeah, why?
Because the Volt catches on fire?
I'd be more attracted to the Cadillac that they're also talking about doing like the Volt.
Like the Volt, yeah.
In any event, let's go on. I had a interesting contact. We were privileged to meet a Mr. John Allen of Westchester, New York, here at the Electric Vehicle Conversion Convention. Fascinating guy. Did not bring his car.
No, I remember that, yeah.
It's a really quite attractive 1994 Toyota Celica.
Okay.
But John has done everything old school with Trojan T1275s, which are the good Trojans, by the way. That's what I had in the gems when and we still have a few of them around. If you had to have a lead acid cell, the Trojans are...
That's the ones, yeah.
Pretty much the ones. He doesn't have a clutch. He uses an Anderson connector for the disconnect. He wants to clean all that up, so he's redoing his Toyota with 180 amp hour China Aviation Lithium Battery Company, previously Sky Energy cells, and has sent us a introductory video to his project.
Oh, cool.
And it actually was fairly well done. The audio was very good, and the car is a delight. I think it's a fun project. Let's take a look.
Okay.
Okay, Jack, this is John Allen, reporting for EVTV. Just giving you an update of what's going on with my lead sled. This is what I used to plug into it, and it used to sit right over here. But today, a rainy day, I managed to clear out my space completely in my workshop and put it into that shed over there, in my garage. So it's a pretty exciting day for me to get that done, and I'm going to go and show you where the car is right now. So there she is. She's finally back in here. This used to be my woodworking shop, so I had a big saw table right there where the car is right now. So I'm still in the process of cleaning up a bit. Not much more to do. So Jack and Brian, here we are. I'll give you a quick guided tour of what it is, what it's like at the moment with the lead acid batteries in it, and a few changes that I'm going to be making. Obviously the lead acid batteries are coming out. There's a few other things. I'm going to be putting the clutch back in, which is one of those levels of safety that I want to put back in. At the moment I just have Lovejoy couplers that are my drive my drive connection basically to the transmission. I want to eliminate the auxiliary battery as well by putting one of the mega packs in and getting rid of the IOTA DC to DC charger. So this is the DC to DC charger I want to eliminate, and I want to put in the mega pack. I want to also change this around and put one of the guest service switches, disconnects, service disconnect instead of this Anderson coupler connector. This is going to go, that's the auxiliary battery, and then I'm going to be basically tidying up and making everything here finger safe. That's one of the goals of this next phase. So I've been running this vehicle on 12 Trojan T1275s for the last almost 2 years. I'm excited to get rid of them. I've been through one set already in less than a year that got destroyed for some reason. I think probably the cold and running them down. So I'm very excited to be getting the lithium. I've got 50 calb 180 amp hour batteries sitting in the basement, and I just can't wait to put them in. So this is the controller from NetGain Controls. It's a 160 volt 1000 amp controller. I'm hoping I can use the same one again, obviously. I'm not sure if it will. I've got to talk to Ryan to see whether it will be okay with 50 calb 180s, because I'm slightly on the margin there with the voltage. So here I have a vacuum pump for the brakes, and the reservoir is down underneath there. I'm okay with this. It doesn't bother me. I've mounted it on a rubber pad, so the sound is muffled, and it hasn't bothered me at all over the last 2 years. So I shall be keeping that. So these are the contactors, or the relays that turn the vehicle on. I have two on the positive side of the battery and one on the negative as a redundant safety. If you turn the ignition off, hopefully at least one of them will disconnect. That was the way that actually Ryan at EVSource had suggested to me to go about doing it. Here's the main fuse, and this is the relay for the heater, and a fuse for that. All of this I want to tidy up and make this look, make this finger safe and make it look neat and tidy. There's a jumble of wires down here, which now I know what I'm dealing with. I can revisit the whole lot again, and hopefully make this look really, really smart. So it's going to be a little bit of work, but I think I'm up for it. Okay, the interior of the car, I'm going to have to make a few changes on that. I've got the NetGain interface here. I'm going to have to find a spot to put the Xantrax, and so I'm probably going to make a little bit of a module up here or something that will hold this and the Xantrax in it together, because there's absolutely nowhere else that I can put the Xantrax in. So that's going to be a bit of a puzzle for me, but I've been thinking about it for quite a few months, and I think that making a little additional housing up here will probably be the trick to do that. Here's the charging port. That's going to be changed for the J1772 receptacle, which I have already. That's going to be switched out. So in the rear, as you can see, I've got my battery charger, the Manzanita Micro, and this big box which is holding 8 Trojan batteries. It's about 560 pounds worth there. And so I would like to be able to drop this whole, the new battery box, down into the wheel well, obviously getting back some of my trunk space, which will be very useful. Okay, so here I have the new adapter plate, and I had to get another transmission due to the fact that I had on the splines where the throw bearing goes, I had welded a bead for my Lovejoy coupler on the one that's in the vehicle so that it wouldn't slide back, and I wouldn't be able to use that same spline anymore. However, I've got the new adapter plate, and I just have to do a little bit of a cutout here for the transaxle clutch, my heavy duty clutch, pressure plate, and then my flywheel, which is pretty heavy, with the adapter for the motor shaft, the connector for the motor shaft, and the bolts. So right over here I've got the connector for the receptacle for the J1772, and also the pistol grip for that, which is going to be a much better system. And I have the guest service switch, which will be better than the Anderson connector that I'm using at the moment. That's always a bit scary when you're switching that, pulling it on and off. As Jack said, you never know, it might melt in your hand one day, so I want to avoid that. I also have the Mega Pack, which I've already set up. I bought 3 Mega Packs, and this will be my 12 volt supply, so that I can eliminate the auxiliary battery. So I'm pretty well set with that. I've got it so it can plug into 110 at the moment, but that was just for testing. So ready to go, ready to do some work now. Very, very exciting stuff. Can't wait to get going. It's been a long time preparing for this, just because I've had other things to do, and my workshop was being used for finishing my kitchen, etc. And now I'm in, and the winter's coming, so it's going to be better to have the car in here anyway and working on it while there's a lot of snow outside. So that's me, John Allen, from New York for EVTV. Excited to get going on this project again.
Well, that'll be a nice project for him to finish up.
Yeah, he's going to put up again a right core Mega Pack DC to DC converter. He's going to go back and put in another transmission with a clutch.
With a clutch, yeah.
A lot of those things, John, are kind of, that's our preference, but you don't have to have a clutch. Right. It's another safety element. But if you're not having any problems shifting,
yeah, that's
I'm
okay.
not sure.
Yeah.
I suspect he is having.
He might have a little bit. Yeah, he could have.
And it can be aggravating when you can't get it into gear. Yeah. But I think you're doing a great thing. It's a good-looking car, certainly for one that's nearly 20 years old.
Yeah, very nice.
And so good luck with the project. Nice. Yeah. Please keep us apprised. I think our viewers would want to know how that comes along. Right. And what kind of problems he runs into.
Yeah, bring it out next year to the Electric Vehicle Conversion Convention here in Cape Girardeau.
I would just as soon have a root canal, but I am going to go public on this because it was pointed out to me how it's in my interest to keep it quiet.
Okay.
By several parties today, and so we're going to out the whole thing. I will always, whenever somebody puts a gun to my head, I usually reach up and pull the trigger. And what that leads to is, of course, it could kill me. But then it's not my problem, is it?
The guy standing there holding the gun?
Yeah, he's kind of got a mess to explain. He might have meant to shoot me, he might not have, but now it's kind of been taken out of his hands.
That's right.
He could have hit me and wound me, in which case it would probably make me really mad.
That's right, that's right.
Now he's got a wounded, bloody guy who's really pissed off at the other end of his gun.
It's like, damn, that hurt.
Or he might miss me completely. That's not good either.
Just have to throw the gun at you and run.
So a couple of years ago in April of 2010, I guess, I sent in a check to what I thought was a pretty good friend of mine, David Coy, had been a converter of RAV4s.
Oh, okay.
And had built up a pretty good business up in Issaquah, Washington, doing that. He expanded his business to include components and was pretty good at chasing them down and got some good components, I thought. And I kind of became a customer. And for a year, I bought batteries from him and different components and so forth. and he was always a pleasure to talk to. In April of 2010, he called and told me about these 200 amp hour cells.
Okay, yeah.
I told him I'd try them. He sent me a couple. I tested them. They were certainly 200 amp hours in the same form factor as the 160s. They were Thunder Skies.
Okay.
And so I ordered 40 of them, and he sent me an invoice, and I sent him a check the same day. And it got there just in time to be cashed before that company folded and absconded with everyone's money, including Dale Friedhoff of St. Louis, who'd spent $16,000 on Calbs or some kind of maybe Thunder Skies with him. Kind of because I
remember when
chided him into doing it.
Remember when he came and talked to us
and he
that
just
afternoon?
got his check in under the thing before the story broke that this company was going business, was going out of business, and was going to keep everybody's money.
Oh, jeez.
So they received our batteries and went selling them again and keeping that money. And all along there was this big blow up with Otmar and David Coy, and James Morrison, and they swore it was James Morrison who was doing all this.
Okay.
Maybe, maybe not.
All right.
James Morrison was an investor in the company. He's kind of a wacko and just got crazy on the whole thing. A group led by Roy Mann of Fremont, New Jersey, in the Pine Barrens of New Jersey, central New Jersey.
Okay, yeah.
Roy he renovates VW Beetles.
Okay.
And had a beautiful little 77 VW Beetle that he had converted to electric drive and showed at car shows. But it was a lead acid car.
Okay.
He had ordered some batteries as part of this, as did many others. There were 23 of us ultimately in this lawsuit filed against James Morrison.
Okay, yeah.
Technically, David Coy was also a defendant.
All right.
But he went to working with the plaintiff group and their lawyer, and he filed a suit against James Morrison. And so he claimed to be on our side.
Okay.
Of course, Morrison didn't really have much. They sold off some of the batteries, kept that money, and we were down to essentially what was left of the inventory in a settlement we did receive. It was worth about 59 cents on the dollar.
I mean, not bad, I guess. Yeah, 59 cents on a dollar.
We talked about you having the ability to buy your batteries, and the ones that didn't want to buy their batteries would receive cash, but you had to pay for them again because your 59 cents didn't cover it.
59 cents didn't cover it.
I agreed to do this with Roy Mann.
Okay.
And then found out that another gentleman, Kimball Petty, had also ordered 200 amp hour cells, and they weren't enough for both of us. They engineered a deal where David Coy would sell all the inventory and give us the money. And the first thing he did was sold my batteries to Kimball Petty.
Oh, no.
It gets worse. Then David Coy disappears.
Okay.
And for a month and a half, no one in this plaintiff's group can contact him at all.
Oh, man.
He's not answering the phone.
Oy.
Meanwhile, his case against James Morrison had been heard, and there's really been no resolution. The judge said he'd take it under advisement. He'll rule on it when he gets ready.
When he gets around to it.
So he's still waiting to see what's going on, I guess. And meanwhile, David Coy runs an online component service called Current EV Tech, and has, according to him, I did speak to him today, he has sold between 20 and 30% of the inventory recovered in the lawsuit. And he intends to keep the money until the end of the year.
Well, that's pretty close.
Well, it is pretty close, except the other group wants to do a distribution in December, and he's already been playing games with who he sells it to, for how much, and so forth. And so the man has sold my cells at least 3 times, claiming that it was James Morrison's doing all along, which James Morrison probably never did know very much about what was going on in the sale of components at all, because James Morrison was an investor and apparently doesn't have enough sense to get in and out of the rain. So it looks at this point that David Coy was the mastermind behind it. I talked to him today and asked him to get this straightened out with his plaintiff group and get back to me. He did not. He said he's already been talking to him, but I had confirmed with Dan Baker and Roy Mann earlier today. Roy, by the way, he sent us a photo of his VW Beetle, is probably going to try to sell it. It might be available. He wants nothing further to do with electric vehicles.
No, man.
He's completely bummed out by the whole legal process. The Attorney General in Washington through all this couldn't care less. It's just like, what's in it for me? I mean, a blatant politician. I guess we'd have paid him something.
Right.
It was just, you know.
Yeah, the campaign contribution.
What's in it for me?
Yeah.
The police up there don't want anything to do with it. They're busy giving out DUIs. There's no consumer protection in the state of Washington. 23 people were defrauded out of $500,000 at least twice by the same guy.
Same guy, yeah.
And he's still running around out there. If you're tempted to buy any components from Current EV Tech, understand that the man that runs it has tagged several of us at least twice on the same batteries. And he's such a charming fellow and a pleasure to talk to, he'll have you wanting to do it again.
Oh, gee. Oh, man.
But I would not buy anything further from Current EV Tech. Of course, they were pointing out to me that if I outed them on this, then he wouldn't be able to sell the rest of the inventory and I wouldn't get my money. Hello, I don't have any money now. I've been out the $9,700 plus another couple $1,000s in legal fees while this all goes around and around David Coy one more time. And so I'm kind of sick of the whole thing. Dale Friedhoff, by the way, has stopped in several times. He's continuing the process. Bought him some more batteries.
He got a whole nother set.
Letting him get him down. We're sticking with it. But do be careful who you give money to on the internet for components. Oddly enough, the Chinese seem to be the most trustworthy when you're sending TTs to China and have no recourse. I've had better luck than when I'm buying from Americans who will simply steal from you and point to somebody else and grab you again. It's like Charlie Brown with a football. So I would not recommend any further expenditures with Current EV Tech, and I trust that'll be the end of that little business, and Mr. Coyle move on to something else. But it appears that he was the problem, probably all along.
Oh, man.
But always with the story about it being someone else.
Someone else, wow.
And so there you have it.
Wow.
I did speak with him today. I don't think anything's going to get any better. He's got the stuff again, is selling it again, and is keeping the money again.
Is this a recurring pattern?
Yes, we actually got a settlement and got the stuff, and they turned around and gave it to him to sell.
That is just so weird.
It is. And he is selling it, and now he's keeping the money.
That is just bizarre.
And this group is now going to try to file something.
Isn't all this stuff in trust or something? Or
no, it's just wandering around loose up there.
Oh, man.
He went and picked up the inventory for him, you see.
Yeah.
He offered to pick them.
Hey, I'll go down and get them. I got a truck.
He went and picked it up and put it in his facility. Now he's selling it and keeping the money again. This is probably a third trip on some of these batteries. The man sold the same battery 3 times. He's wearing the spots off of them. And we haven't even gotten anything going there.
Oh, man.
Let's take a break.
NetGain Controls introduces the new Warp Drive Industrial Controller. The Industrial is designed to handle a maximum of 1400 amps and up to a 360 volt nominal battery pack. The unit's rugged design looks and works great in the automotive environment while protecting it from the elements. In addition to higher continuous currents than the classic warp drive controller, the Industrial comes with several major enhancements. Liquid cooling is available and uses leak-free and rugged AN fittings. The Industrial controller has complete isolation on both throttle channels, giving the highest possible immunity from situations that might affect the electrical throttle input. High voltage connections are fully protected underneath the sealed cover. Voltage leaks between vehicle chassis and a battery pack are detected, alerting the user to potential safety problems. Controller settings can be completely customized using the NetGain Controls Interface module, which can also log data to an onboard SD card. The controller weighs in at 25 pounds. Visit www.ngcontrols.com to order your Warp Drive Industrial Controller now.
Let's talk about the Swallow.
Yeah, here it is. Hopefully you can see a little bit of difference from last week.
Not much. It's grown a bottle of tequila.
It's grown a bottle of tequila. That's a good thing. It's a
Actually,
magic
there's
swallow.
some neat stuff going on back here. We did receive the controller and the motor.
We did receive the control and the motor.
Let's talk about something we can't show them at all because it's all gone away right now.
Okay, okay.
We went to Lucian. What
yeah.
odd thing did you determine to do with it?
Well, what we did is, we're trying to keep, for Lee, the cost down as much as we can and use whatever we can. I mean, some of these parts were just broken.
We've used up all his money.
Yeah, we've used up all his money.
A little bit of mine.
Yeah, that's right. So it's like, all right. So he had an adapter on here. There was a motor on there. And
had a little close clearance on the back to the body, too.
The clearance was very, very close. And we're going from a motor that is, 14 and, 3/8 inches long to, or 14 and something. We're going to be a ½ inch shorter with the motor.
Really?
But we're 3/4 of an inch larger the diameter of the new motor. We went from 8 1/4 to a 9-inch motor. So that would be, 3/8 of an inch, possibly on the top. So what I'm hoping is that by being able to bring the motor back a ½ an inch and only go up 3/8 of an inch.
You're going to get me to my 32nd of an inch loss again.
Right, and it was already touching anyway.
Yeah,
the other motor was already touching.
Yeah.
So
we're going from an 8-inch ADC, which is locked up, to a gorgeous new AC50 9-inch. It's not really 9-inch.
No, not really.
It's 8 3/4 inch or something.
Yeah.
At the outside thing, it's really like an 8.5 inch motor.
Yeah.
And but it's a very nice motor and a new controller.
Right, the Curtis 650.
But you have a very thin adapter plate, this short barrel piece, and a very unusual coupler to the flywheel.
Yeah, it was kind of different.
Where the shaft of the transmission actually goes into the shaft of the motor.
Right, in the couplers that we've been using, we use the stock VW flywheel attachment, which is a big gland nut that has needle bearings inside of it. What that does is it forces us to use an adapter that is longer. It makes the motor, the whole thing longer, to push it out maybe an inch, inch and a half. Will definitely be into the body. So he had this little adapter that they hogged out the holes for the dowel pins. They don't use the gland nuts, and when it mates together, the input shaft and the transmission sticking out here actually goes into the shaft of the motor.
And it had a little bushing.
It has a little brass bushing that it rides on. So what that allows is this whole thing to be shorter. It's not nearly as big because we have to have a bigger coupler. We have to have the taper lock, and it makes our barrel spacer.
So what are you
thicker.
doing to try to get his adapter working with our motor?
Well, what we're doing, so we went from a 8 to a 9-inch or 8 1/4 to a little less than a 9-inch. So the plan is to take his existing barrel spacer and his existing transmission adapter to bolt it up to the VW transmission and to use it. So what the plan is,
you're actually going to tap new holes into the motor?
Tap new holes into that into the end plate on the motor, and go ahead and affix that ring, that adapter ring. That'll allow us to put use his adapter. We're going to shorten the shaft by a ½ an inch, and go ahead and remount the inside of the shaft to accommodate the input shaft, and it goes in about, I think, 1 5/8 inches.
The high-performance electric vehicle systems motor, the AC50 we're talking about, normally comes with an aux tail shaft,
Yes.
which is kind of tricky because it has to have an encoder
Yes.
on the back end to provide motor position to the Curtis controller. We've got it all worked out. Originally, they were shipping them without an aux shaft.
Without an aux shaft. Now,
But they figured out how to do an aux shaft with the encoder, and now that's normally how they
now
ship.
that's if you order one, that's what you get is that
But
aux
you
shaft.
can call them and order one without the aux shaft, and that's what we
Which
did.
we did, yeah, exactly.
So we can have a chance at getting that motor into the car.
Yeah.
Tell me about your little towel rack here.
Well, what we did is, there was a kind of a triangulated roll bar thing here that was
Yeah, that
really
was
a
very
headrest
strange.
almost. That wasn't particularly attractive. That it was kind of falling apart, and it really wasn't very strong either. It was bolted to the frame horn, the transmission, and I think over here one of these upper.
And they kind of had seat belts just bolted to the pan. or
Right
something,
here, these just little seat belts, not very interesting.
and not very secure.
Not very secure, just a regular lap belt, and not very wide either from this point to this point. Those were your seatbelt attachments. So one of the things that we had talked about was putting in some 4-point harnesses like are in the Spider. The issue with 4-point harnesses is you have to have some place to anchor the shoulder straps. So what we have fabricated here is a just out of 1.5 box, 1.5 square tube is on the mounting stock VW body mounting points, which they're not using at all. Is just this little tube here that gives us a place to anchor our shoulder straps for the harnesses. We've also put them in the proper place. They're supposed to be below you. Supposed to be below your shoulders. A lot of times people end up with them above you. Not a very good thing. I mean, if you're really in a roll or something, you want that to be pulling you into the seat, not you to come out into the top of the shoulder straps. So the seats will be about this high, shoulder straps coming here. This is all below a little package tray that's in the back of the car.
Okay.
What that also allowed us to do was use a couple of tabs here that we welded in and another of the 2 mounting bolts to put one of these aluminum trays up here with that your corrugated aluminum.
Someone called and asked about that. I had to track down where I got it. I don't know if they have any more of it. It's called aluminum honeycomb boat and aircraft decking.
Really?
I got it from Online Metal Supply, and 2 probably 24 by 48 inch sheets.
Yeah, we
Is that
only
about
got
what
a
I
couple
had?
of them. Yeah.
Were they 36 by 48 or 24 by 48?
I don't remember.
The 2 of them together were $197, so they were quite expensive, but they're quite light and they're quite rigid. Don't hold the screw real good.
No.
But I see you've got that worked out. I think that'll make an excellent heat sink for our controller, and we'll be able to put our contactors and
Yeah, we've got
so
a shelf
forth.
for all kinds of stuff, and
Yeah.
probably more shelf space
And
than
now
we need.
the stuff is on the chassis instead of in the body, where you have to, and so it'll be easy to lift the body up.
Yeah,
after
before
that.
everything was mounted, the controller it was mounted. It was all mounted to the back of basically the back here of the car, and it just.
I see we've got the battery boxes basically done. We're not really wired up.
No, we've got one battery box wired up.
This is going to be our positive terminal. We're going to go back through to here, to this center section. Short cable from here to this terminal on this box, through that box, out the far side. We have a, that is a 500 amp, 50 millivolt shunt for the Xantrax to measure current.
Oh yeah, okay,
there.
right there, good.
And then a 500 ampere Ferraz Shaw Mutt fuse.
Our fuse, yeah.
Which is where you can get to it. And then we will have our cable right here connect to our most negative terminal, I suppose. This will go to the box here, will come out of that side to your cables and out the
They're
back.
coming, run through the tunnel and coming out the back.
We're Rod Holzhauser. Is he our intern? The guy's in his 60s, but
he's a big help.
he is a big help. He did our welding.
He's pretty
our
good.
Thing.
Yeah.
But here is our connections for our Xantrex to measure current. Here is our thing. He made us a little box out of just ABS plastic that goes over here, and we put a bolt mat on it, and it's sort of touch proof here. I mean, I guess you could get a finger in and touch this bolt if you wanted.
But really, and this is way back in that little front access area, so I mean, someone getting back there, they really got to work at it.
You're gonna have to reach hard.
Yeah, you really got to work at it.
And so it made us a nice little cover over that. We've got a cover over this. We'll hook one cable to this terminal, the other one to this one. Pull them back through there. Go to your contactor and your controller, and of course I've got the connection here. You've already hooked up
with
all the connections
DC
for
to DC converter is ready to go.
I wind up with this goes to the negative pack,
and
this is our 12 volt. We'll have to do a little single post 12 volt unswitched on here, and that will be our work on the battery boxes. We don't have the straps in yet. I've got those strapped up, but I'll strap all this up tomorrow, Monday. And once we have the batteries in and strapped up and going, the rest of this doesn't amount to anything. And you're saying the adapter, you're not even doing anything on the adapter. You're making a change to the motor.
Making just drilling 4 holes basically in the motor and changing the shaft and boring out the shaft a little bit to accept the input from the transmission.
So you have to do a little in the end of the shaft.
Which it had anyway, it just wasn't as big, and we're taking 1/2 inch off the shaft.
And take 1/2 inch off.
Yeah.
Sounds good.
Yep. That'll give us a shot at keeping that motor as tight and close as we can, and maybe not having to do anything with the body.
Brian, we're going to be near enough rolling on this next week. I don't see any reason why not. Again, what happens is you fight it and fight it and fight it until you get to this point where the battery box is done. The rest of it sort of falls out.
Yeah,
It's never amounted to anything for us.
No, it's not that big of a deal at this point. Yeah, half of it was up here.
Yeah. We've still got to run our accelerator wiring. I don't know how we're going to do that. We've got a coupler somewhere that hooks up to that. And that's that. What did you do on the Escalade this week?
Well, let's take a look.
All right.
All right, so we're back under the Escalade here. Rod Holzhauser is down here, the Baron we call him, the Baron von Holzhauser. And Rod's been helping us do some stuff. He's supposed to be somewhere. His wife doesn't know where he is, or the hospital. You have to report back. Yeah, okay. So we are working on the Escalade. You know, we've been working on Lee Moorhead's Swallow project for a while, and we'll show you what's going on with that as well. But we've drilled some test holes up here because we're going to have gland nuts. We found that from the top of the deck, where the battery box is, to the bottom here, there's a gap. There's a cavity. So we're going to go ahead and fashion out of gland nuts and some tubing, some PVC tubing, kind of a chase so we can send those cables down so that they don't get chafed on any metal. And we ran some test holes, and I actually feel better today. We did that yesterday, that we can get straight up with the drill, we can come down with the drill and get all that. So we'll be pretty straight. The main thing was up here with this cross member that we could actually get a drill up there and get a hole saw in there.
Yeah, you were lucky to find a gap.
So we got that.
4-inch gap.
So today we're going to do the same thing on the other side. Now the other side has the fuel tank, and you can see it here. It's not too bad, we hope, to disconnect. We're at a point now where we've from this side right up in here, if you can see, I'm going up here. We've taken off I think the evaporative system. Yeah. We've taken that off with a couple of fittings they say are really easy to do.
Quick disconnects.
Yeah, quick disconnects that are not that quick. You just have to muscle them out. The fuel filler on the other end, we had the same thing. Rod has taken the straps off. They look familiar to what we used found in the Mini Cooper. In fact, we get you here. We use these to hold the battery boxes up under the seats in a Mini Cooper. So we don't think we're going to have to use these, but we've taken those off as well. We've got a transmission jack you can see here on the tank. It shouldn't have more than a gallon of gas. I took it back from Sling Blade when they put in the Hydro Boost brake system, and I was on the empty light the whole way back. So there might be a gallon of gas in there or less. So Rod's going to go ahead, and I'm going to stand here, and we're going to go ahead and just drop this. Yeah, we're just going to drop it an inch or two just to see, because there should be a wiring harness or something in there that we're going to have to deal with.
Drop down and go back.
And go back my way. Okay. So you may miss me on the camera, but you'll hear me if I scream. Okay.
Now I'm off.
Okay, you're off?
Can I come back to you some more?
You know, if I begin to drop it down, there we go. Okay, I found, hang on a second here. I found something, nope, not connected. Okay, we're good.
Disconnected.
Yeah, we got everything just about disconnected, yeah.
So I need to come back to you.
You can. Yep, we can come back. Yeah. Okay, go ahead and drop her down. Because it's really light. It's very, very empty.
We're going to have to hold it in the air to disconnect the...
Yeah. There should be some.
There
should be some cables and things up there. Okay, come
Still got to go back some. Oh, your filler light.
Huh? Oh, my end's on the lift.
I'll get you. That's on the left now.
Okay, now we can start to see the wires and things up here. Okay. No, there's a wiring harness over there. And you got something way up there in the front, too. Can you see it, Rod?
I got this disconnected here.
There's something further up, like toward the... Mick, if you come back here, you might be able to see it.
It's not right here.
Yeah, that's a wiring harness. Yeah, there's Jack. And then there's also maybe one more thing. See it way up there, Rod? Way, way up there. Yeah, one more. But that wiring harness has got to come off.
Usual wiring harness problem, right?
Well, it ought to come right off now.
There we go. Okay. All right. Okay. So let's lower this some more, huh?
Yeah. And that's using your head.
Yeah. See, he used his head. Just oh, wait a second. This is stuck up in there. Here we go. Okay, so now you can see, I hope, as this is coming down, there's a big old cavity there. This thing's light. What we're going to do, I'm going to get over here. I'm going to go ahead and lift this off. Okay. We'll just set it on the ground here. Okay, so there was that. So there was one connection that we didn't find. All right. So, you know, go ahead and complain. All right, so as you can see now, let's see if we get the camera up here. We have quite a bit of room now. You're looking from back here where I am, all this room, looking at the wheel, up on the other side of the drive line, up to the front, and to the rear of the transfer case. So we've taken the exhaust from this side here, the fuel tank from this side here, and we're going to go ahead and run some pilot holes up here, do some measuring, and we'll be able to get some Whoop, there I am. And we'll be able to get some gland nuts up there and start working with our cabling. All right. Well, thanks, Rod.
You're welcome.
NetGain Motors, home of the Warp, Transwarp, and Impulse motors, introduced the improved Warp 9 motor. The Warp 9 is a 9 1/4 diameter series wound DC motor with a double-ended shaft featuring 26 improvements for 2010. Externally, the terminal studs have been enlarged from 3/8 to 1/2 inch diameter. Bigger is better. On the inside, a larger commutator, new brush composition, and split brush design with heavier springs handle even higher voltages and currents than before. Our new fan increases airflow by almost 50% over typical paddle-style fans. And all this translates into improved performance. For even more performance or larger applications, take a look at NetGain's Warp 11 motor, an 11 3/4 diameter series wound DC motor for even greater torque and power. Since 2002, NetGain Motors has been leading the EV industry with precision, performance, and price. Visit us at go-ev.com. NetGain Motors, warp power to go.
Well, hopefully you can see what happened.
I feel like Cortez landed in Mexico. Let's burn the ships. Once the gas tank's out, I always feel like there's no going back.
There's no going back.
We could have changed our mind all along.
Yeah, but
now we're going.
Yeah, that's it.
I was very concerned. You had expressed some concern, and I had caught it about getting through various levels of tin and being in the right place. And I was sure we were going to wind up with a battery box 1/2 inch too long after we'd put all that work in.
Drill right through the bottom of it.
But you got right through, and it's all going to work out with your little polyethylene pipes and gland nuts. And we're going to have like 4/0 cable.
4/0 coming out of there. Yep, through the box.
And our cooling tubes.
Cooling tubes. Yep. Yeah, we just had to, we had to get up there, and then we did it on one side and looked at it and just basically took a long bit and ran an exploratory hole. And I'm confident now that we can do that.
Okay. The A123 cells.
Yes. Yeah. You've been working away on those things.
I have been playing on them a lot.
We can't stop him.
We could have done a lot of neat things, but instead I've been playing with the A123
resins,
cells.
batteries, and stuff.
It doesn't make a lick. And I knew that would be a pain in the ass when I picked up the
we said
first
that,
cell.
yeah.
Well, it is. Let's take a look.
All right.
Well, let's talk about batteries. We've got a lot going on. Winston Battery Company, one of our sponsors, no longer speaks with us. They have turned it over to Balcon, and they don't speak with us either. We're still running a commercial and have a bunch of batteries from them and can't talk to anybody about Thunder Sky batteries. Sinopoly is interesting. They love to talk. They talk to us all the time. We've never found anyone who's actually purchased any of these cells and received them. Per Eklund, who was in our recent show, said in Sweden there is a guy he knows and he's sure he's gotten them, but I can't find anyone firsthand, mano a mano, who has received any Sinopoly batteries. Headway, meanwhile, has a new high-power cell that's supposed to be all the begonias. We're going to try to get some and play with them. Calb is shipping, and we, of course, are using some that we got in less than a week from their Pomona facility in the Swallow. And of course we have our cells, the 400 amp hour cells that were provided previously by Winston for our Escalade build. So I guess we will continue to run the commercial. I don't know what you should do about ordering any because there's nobody home at Winston. But we appreciate the support. Things are very strange in battery land these days. I had discussed the A123 pouch cells, and here is kind of an early version of a module that I did with a cast epoxy, kind of some little clips made out of 14 gauge wire to force the tabs up against plates that go over the front of the device and bolt down into very large terminals, but thin ones. We've also played with some little combs made of aluminum to do the same thing. But we've gotten to where we've learned how to fold these tabs over in pairs to make them stand up against the plate, and that's working pretty well. We're working on a module design for the A123 cells. A123 is a peculiarly poetic and interesting case. This is a company that has been early and often with interesting cell chemistry design that has been used quite successfully in DeWalt and Black & Decker power tools in their cylindrical versions. The basis of the cell is a nanopowder cathode, but it's really a pretty ordinary lithium iron phosphate cathode. It does use some sort of lithium titanate anode in some cases. I think the current ones are carbon anode, and they're doing it in these 20 amp hour pouches. Now there's really not a lot different here. If you took 4 or 5 of these pouches and stood them together and put them in a blue plastic case and gathered those tabs together with a claw that you could put a screw down in, you've kind of got your CALB 100 amp hour plastic prismatic cell. So there's not a whole lot of difference here. Without the plastic and without the claw, you have a lighter, a less expensive package. Unfortunately, as I predicted several years ago, if an American battery manufacturer ever did merge, instead of selling you a 100 amp hour cell and it actually coming in at 105, they would declare if they'd ever had one that was 100, they were all hundreds, and you get them and they'd be 95. These cells are coming in at anywhere from 18 to 19.5 amp hours. We haven't caught one in the act of being 20 amp hours yet. We're not too sure what they are. Here's what we think happened. We believe that A123 had contracted with some companies, some factories in both Korea and China to make these cells for them. And they had obligated to a certain minimum quantity, and they would pay them for these cells. A123 was then going to assemble the cells with some magic sauce battery management system and module, which we have shown before, but I'm going to throw in here where you can see how A123 makes a module. And that is the A123 value add. As it turns out, they don't really make the cells per se. There is rumors that they do make them somewhere in the U.S. In small quantities, and we have seen them show making foils and so forth, but I think that's mostly R&D. The factories have apparently, A123 has not met their minimums, and I believe the factories have gone rogue on them and are selling their cells, complete with A123 printing on it, to the rest of the world. We've got a couple cells here They say made in USA, you can see, and then that's blocked out with some magic marker. A123 systems, this being an A2. I don't know if this is a grading system or what, and you have your negative and your positive cell tab here. This is really no different than what you get in the China Aviation Lithium Battery Company package, except we don't have the blue plastic case stacking these up and a couple of metal claws that gather these tabs and give you a place to put a screw terminal. That provides some advantages in that we can do our own design. It has some disadvantages in that we have to do our own module design. And do we need all the battery management system and thermal system that they have in their, what I consider, over-designed module? I don't know. But we're able to get the cells. I have got them down to $22 a cell for a 20 amp hour cell that will never do 20 amp hours, 18, 19 amp hours typically. And we're negotiating the $20 level. Now these were $50 a month ago. And so I think the price is rapidly devolving to whatever the factory can dump these for, at about what they were getting paid by A123 for the cells. How long this will go on, I have no way of predicting. I'm surprised that it happens at all. A123 has received $32 million from a company in Japan called IHI, and they are licensed to produce these cells. But I don't know why they would if they're cheaply available from Korea and China. They could use them in any event. But the cells, we found at least 2 Chinese trading companies actively selling them, and with known customers having purchased, ordered, and received them. And indeed, we have received sample sets of cells from both companies, OSN Power and Shenzhen Vic Power. And I will put up the contact information for both of those companies. But we're down to about $22 per cell in a 250 quantity, which would be about as much as you'd want for a car, 250 or 300 of these. And so we see a future with these A123 cells. They are LiFePO4, which is not a metal oxide cathode, and I think is much safer than the Volt and Leaf cells. And so this is an option. You're not going to get more density. Do not be misled that because these are lighter without the module, that they'll be lighter with the module. You're not going to get more battery in less space or less weight than you do with the ordinary prismatics we get from Calb or the other Chinese trading companies. What you do get is a much higher power density. These individual cells are capable of putting out 2,400 watts of power at 3.3 volts. That's 400 amps. 400 amps out of a 20 amp hour cell is a lot. Now, that's 20C, and it can do that briefly. When you put 5 or 6 of these together, you get a lot of current capacity. And so it opens up the ability to do a more customized granular pack for your car at considerably more work, but also to have a lighter pack. Let's get real and say, hey, I don't want to spend all that money, Jack, on a 100-mile range car. The 50-mile range I was getting with the lead was fine. I just don't want all that weight. Well, hey, here's an opportunity. You can drive any of the controllers at full power, full acceleration, at half the weight that we've been doing with a car if you're willing to give up the range. Now, energy is not free, and so there isn't, any any port in a storm here that you're going to get a freebie. But here is another option where you could do this. We're kind of not packaging experts, and there's so many of you that would do this so much better. I'm trying to figure out a way to get some viewers to put together some packages of stuff that could be done, kind of an open source type concept of let's design a module. So I'll show you mine if you'll show me yours, and I'm open to the idea of some sort of a contest, even with me on the hook for the prize, and a substantial prize for a winning entry. And I'd like to see these designs at our electric vehicle conversion convention next September and have them all arrayed on a table for our attendees to not only view, but the winners and even the non-winners, if they were selected by individuals, could actually sell these. I don't really have any interest in being in the business. I will be if I have to be to make this go. Here's my latest version. It uses a, here's some earlier versions. They're kind of bent and ragged and have had a tough life. I'm getting better. Of this one I like better. This uses a cast urethane, not a cast epoxy. We've gone to a different kind of nutsert, not the large 1/4 inch screws, but the number 10, 24 thread per inch. This is a little device called a 1024 by 10 millimeter insert nut type B. And this has some little ferrules on it and a face, and you're supposed to drive this into a piece of wood, and thereafter you can put a screw in here and it'll hold. Well, we're not going to do that. What I'm doing is putting them in my mold where the face is actually at the back, and my little screws come in at the front in the narrow part of the mold. And what that allows me to do is put an extreme amount of pressure, assuming I use a hard enough screw. This is a little 1024 1/2-inch screw, 24 threads per inch, but it's in a 3/16 stainless steel. And it goes into the narrow part of that, pulling on our tab. The wide base is on the back, and so we have this cone that I'm trying to pull up through the urethane. Here's a little paper thing I use, draw it out on a computer, and I can draw my holes in my mold. I make the mold out of ultra-high molecular weight polyethylene. And that's because this is a neat material. It's got great dielectric. We use it around here, but it's difficult to use because nothing will stick to it. You can't glue it. You can't, no adhesive will work with this. Well, that's what I want in a mold, because I'm going to break out the epoxy, or the in this case, urethane, from it. And so then we need to account for tabs, where we have slots that the tabs can go through into this end piece like this, and then I can fold the tabs over, and by applying a piece of metal over that, I can connect it to the other tabs. Now, I really have learned to fold these tabs with another one so that it projects, so when I clamp down this plate using these screws, it actually has some force. We also, if you're not going to be able to see this, but on my end plate here, because of the way we use this, a little meniscus forms along the edge of the plates that we use for the slots, projecting that up from the surface of the end plate. I've got my little nutserts in there and fill it up right to the top where these don't project, and that gets a little bit of an edge to my thing. And that's important, that you get pressure on all those tabs fairly evenly in operation and in a vibration environment. So don't you like the color? It looks like old ivory, bone or something. And this does not bend. It's quite stiff. The most amazing thing is how quickly you can make one of these things with this very hot urethane plastic. I printed out my latest version, put it in my ultra-high molecular, and drilled holes in the bottom where my screws were going to be. And I've taken 1-inch 1024 screws here. And now what's left to do is simply take these nutserts that you get from McMaster Car and simply screw them down where the flat side of the nutsert is firm against the thing, with the screw projecting out the nutsert. And that keeps epoxy from getting down in the nutsert and binding it to the screw too much. And we're going to do this with all the screws. Before we place our metal thing. Now we've added another plate. I used to do 5 tabs, but I was seeking a 100 amp hour cell. Well, 5 18 amp hour cells don't add up to 100. So what I've had to do is go to 6. We will then be slightly above 100 amp hours in our module. Now the other thing that we do, if you notice on my thing here, is we have one set of tabs that's right by the edge, then a gap where we have our screws, and then another set of tabs, and then another gap. If I turn that around to the other end, that will be reversed. And so I can take 2 sets of these and interleave them with terminals at the ends. Here's the other little thing that we're doing. Here is like a little plate. It's thin aluminum, has holes in it. Now we're not going to continue using these 1/2-inch 3/16 Phillips head screws. I've ordered some socket head screws that have what's called that all clad or something coating, all coating, that is supposed to be much better against resistance than either zinc or cadmium coated screws, and it's a grade 8 screw, so very hard. This will let me come on down on that screw and mash this plate down, actually deforming it a little bit onto my terminal tabs. But the interesting thing is that we've played around at 200 or 300 amps with these cells. They do not have unusually finicky thermal characteristics. They do get somewhat warm, but right up around the tabs on the cell. I found that these little aluminum plates are actually quite good at dissipating the heat. And so instead of having a thermal system with water tubes going through it or whatever, we're simply going to use kind of a mince but thin aluminum plates as our current conducting terminals. And this should wick the heat away from the cells quite adequately, even at quite high current levels. And we've done this at 400 or 500 amps, both in and out, and it works pretty well. There is some temperature buildup on the plate, but barely, and they remain remarkably cool at those levels, so I don't expect them to get a whole lot warmer at higher things. So we screw all this down, and here is my little inserts. Now the whole concept here in this module is these inserts. They're going to be buried in our urethane, and in fact, when you screw into them with a screw, so these screws holding them in are just temporary, and they're just to clamp them down to the polyethylene. And then when we get done, we will actually remove all these screws and pull it free of the form. Meanwhile, we have to position our tab thing. Now, this is a weak part of my design. I don't really have a good way of positioning the tabs in the same place every time. I get kind of close eyeballing it, but there we have our mold with our plates to form tab slots in the finished product. We have tried 8 or 10 different formulations of epoxy and urethane. Right now, I'm all gaga, and this is subject to change from one to the next. We're going to try something different. In fact, today, by Dascar Plastics RP40. This is Dascar Plastics of Dowagiac, Michigan. And we'll put their website up here. It's www.dascarplastics.com. This is their RP40. Has a number of interesting characteristics. One is that it's got a very short pot time and very short to demold. Number two, it turns this lovely color, and it's quite hard. And number three is it's good up to about 350 degrees Fahrenheit, and temperature is one of our main things. We've had them so hard and brittle that I couldn't take this out without it breaking. And we've had them so soft that 2 weeks after I did them, they're still bending whenever I do this. So finding the right formulation has been a big adventure. Today, I'm going to take 6 ounces of my resin, my side A, and I'm going to put it in this measuring cup, and size does matter, guys. You have to measure this fairly carefully to be precise. And that is 6 ounces of the resin. I'm going to add 6 ounces of side B, which I think is the hardener. Now, I may have those backwards. They talk about A and B. Bring that up to 12 ounces. And this has a 2-minute pot life, which is going to be kind of an interesting thing because I'm going to do something very different here. And that is, this is some silica filler. And you can add sand and different things to your mix to give it different characteristics. Today, I'm going to use this silica filler if I can get it out in time to do any good with it. And we're going to push that up to about, let's see, 6, 12, 18 ounces. And so I'm going to dump enough of that in there to get us up to about 18 ounces. Not a very exact measurement, but some silica filler. And now I'm going to mix it because we're running out of time already. And see if I can mix this up. The silica does not seem to want to mix with it at all. So that is kind of a failure so far. If I can't get it in there. It's snowing. Yeah, it's getting mixed in there a little bit, but I'm running out of time. That's probably why. So we better get this in there in our mold before it sets up, because when it sets up, it goes quick. Got a little silica in it, I think. I'm not even concerned about this running over my mold edges. What I really want is it to be full. And that is because I want it to come up to the very edge of that piece of stuff. I can see I'm a little out of level here. Let me see if I can shim this just a bit to get it just a little cocked up there. And the other interesting thing about this is it doesn't take any time to set up. This will be entirely set up here in less than 15 minutes. Yeah, it says demold time 15 minutes. I'll catch you back here then. It does so more in the form where it's deep than it does out here. This is fairly thin, just laying on the top, where this is already almost solid to the touch in the white part in the mold. That's because it's thicker in the mold. And so this thing is already setting up. I think this silica will make it a little stronger and a little lighter, just this fill material. That's what we're experimenting with. As you can see here, this is already solid to the touch. It's been about 2 minutes, but it's very, very warm. This is stickier and cooler because you don't have the mass of the resin and hardener together. Okay, it's 15 minutes later. As you can see, our stuff has cured. The temperature has dropped. It's kind of a bubbly looking thing because of that filler, I imagine. I'm leaving the screws in from the back side because the first thing we have to do is get our tab slot form out of here, and that kind of takes a little bit of force. It's quite a bit of area there, and I just work it back and forth, whack that a little bit. That brings it out just a hair. Turn it over, whack it again. It's starting to come loose. Let's do it again. This is usually when things start falling off the bench and onto the floor for me. There it comes. We kind of keep a little wax on here so it won't stick too bad. And here we can see our slots where it was. And we've got all our screws still holding this in with our form. I'll take my handy dandy screwdriver and inexpensive. And so while this form and this sort of thing is a problem right now in the development, eventually it's going to be an asset, and we'll be able to have forms made that are very precision and so forth. I turn this over. I can take the screw and stick it back in here from this direction, which is actually how we're going to use them. And I actually can pick this whole thing up out of the form, and it pops loose just that easily. This is not quite as strong and a little more flexible from the filler, and so this tears off quite readily. And the whole thing seems to me to be lighter than what we've been doing here because of the addition of these little silica bubbles, essentially, that make it lighter, and you can feel that it's lighter, but it still seems quite stiff and quite strong, and I think that's going to work. Now, if you'll notice, there are no slots on this side, and there are on this side. That's because this didn't get all the way down flat on our mold, and we got a little bit of the stuff underneath it. But if I hit this with a wire brush, I can score that thin film of, you can actually kind of see the slots through the thin film of that have it done. Now I could do that with a pocket knife, for example, if I wanted to spend the day with it, and just stick it down through there and see there's a slot. And there's another one. But I usually hit it with a wire brush on the buffer wheel and kind of dig those out. Although this is working pretty well. There is 1, 2, 3. Ready to go?
I left it on all the time.
Yep, well, we're back. Here's some stuff. We hit the wire wheel, and we're through the stuff. Basically, what you do is slip the tabs through, and up they stick. Let me grab another one. Now you want to be careful that you get them going the right direction. In the same direction as the one next to it, otherwise it'll make quite a mess. So here we go. We've got 2 tabs. I said that we're working away from the little pieces of hardware. Got a little flat nose, needle nose pliers. What I do is bend them both out this way and bend this one, the one next to it, over it, and kind of shove it down with the nose of the pliers where it's kind of bent down in a crease between the 2 tabs. And then you can take the pliers and kind of fold them over this way and down. And what that does is form a little roll with the tabs. If you ever need to take this apart, and I do periodically, you get your tabs back. But you make a little roll. That's a couple layers that sticks up there. Now if I take a plate and screw that down here with my screws, it'll smash those flat, and they'll have good connectivity to each other and good connectivity to the plate. And if I do that on 3 sets, then we're there. Again, we've modified this from 5 that we were doing to 6. And that gives me a 24-cell module that interleaves, and I have one of these on each end, and that gives me a 28-pound, 28.5 pound, really. I might get rid of a half pound with that silica filler, I'm hoping. And that gets us our module. Now, we still don't have a case around the outside, but we have 6 parallel A123 cells and 4 in series, and in about the size of a small absorbed glass mat battery. In fact, you could fit it into a car and use it that way. You have a little bit of a challenge in that your terminals look something like this, a piece of flat aluminum plate. This is a template I have for one. Although in this case, I have just added these 2 holes here so that, because I was having a little problem with these corners with them actually coming together. And so I've added these 2 holes in this version and some silica fill to lighten it, and I still seem to be plenty strong. And I don't think that will affect my temperature resistance at all. And so we have 170 millimeter on a side, square end piece, and they're about, it's 227 millimeters with the tabs, so about 200 millimeters. It's probably about that with the 2 end pieces, about 225 millimeters long and 170 millimeters on a side, volumetrically. And it's going to weigh a little over 28 pounds without the thing. Now, 4 100 amp hour Calb cells is right at 28 pounds. And so we have gained nothing on weight and very little on volume in going this way. But that 100 amp hour pack here should be capable really of putting out 2,000 amps without any sweat at all, which the 100 amp hour calibs couldn't possibly do. And so that's sort of the difference. I think a 100 amp hour pack would drive a car with some force, if not with some distance. And so we're going to continue working on this. As I say, this is about the 8th or 9th one of these I've done. We're going to have to work on that mixing the silica. Probably you put it in the thing first and pour the stuff in on top of it. And some of these don't really like silica fill. I'm going to have to do some more reading on that. But again, we're going away from, right now, I'm using 1024 half-inch stainless Phillips heads, and they will thread right into these holes. And that's how we hold our plates down. And you can put some force on them because that insert, you have the flat side, the big part of the insert. Again, this is what it looks like. The insert being pulled through our material. It's not going to come through. And with those knurls on it, it's not going to turn. And so all that's left is if you stripped out the threads inside the threaded insert. And so that's the key to this design. It's a little bit complicated. I've seen some things with holes in the tabs and little blocks that I kind of like. Different people are working on different things. This is kind of the direction I'm going. I think with these plates on the end, I get out of some thermal issues kind of automatically. And my connections can be clean and tight. We could even, you know, like solder a big cable to another plate and put it plate to plate on here and have great contact. This is kind of like the GBS terminals, except bigger and with stronger nutserts and screws. I tried to get them to go to a socket head screw and do everything a little bit bigger, and they didn't want to. So that's my module concept. Let's go take a look at that in action on the test bench. I think I can get 100 amp hours out of one of these now. This episode of EVTV is brought to you by the Winston Battery Company Limited, makers of high-capacity lithium-yttrium rare earth cells, including the popular 160 amp hour model featuring cycle lives in excess of 5,000 cycles when discharged to 70%, the longest useful working life of any available battery of any chemistry. A leading battery technology scientist, inventor, and entrepreneur since 1995, Mr. Winston Chung envisions a new world of clean electric power for the dawn of a new era of electric vehicles. For your next electric vehicle design project, contact Winston Battery Limited. Energy for a bright future. Alrighty, let me talk about our setup a little bit. This is our pack. I've got a couple of straps, two ends. On this end, you can see a plate, and a long plate. We have a set of cells here, 6. This is negative, this is positive. This plate ties it to the next set. These are negative, this is positive. This positive, I have a copper strap that goes around to the back, and it's identical over here. It hooks up to the negative, negative, positive, negative, positive. And so here is my positive terminal, and here is my negative terminal. I've got the cable simply clamped down with one of the screws to the negative side, and our other massive cable, 2-aught cable, to the other one. When I turn this on, this power supply closes a connector, and that goes over to our load where we're doing about right at 50 amps of current. Right now I'm at 91 amp hours on my Kubler process meter that our friends at Global sent us to count amp hours. That's gotten to be kind of a staple here in the lab and would work in a car quite well. They're about $350 and much more visible, as you can see, than a Xantrex is. My multimeter, I don't know if you can see it the way we've got this set up right now. It's showing 12.63, and I've got my little cell log 8S where I can watch each of the cells. They're at about 3.16 volts each, but it takes a magnifying glass for me to be able to read them. One of the reasons that's kind of fallen out of. Recall this little Molex connector to the wires got soft and two of the wires touched in my Speedster and started a fire. I don't mind using it here in the lab. I would not put it in a car. Again, we've just had abysmal results with even simple battery management systems in that they're just not sufficiently robust for automotive work. And in designing an A123 pack, remember, one of the reasons A123 won't sell them to us is because David Andrea, who now does battery management systems for the EV community, had burnt a Prius to the ground by making a pack with their cells and putting it in a Prius, and it was simply a function of washers and connections that had worked loose in that thermally cycling a vibration environment. We are forced to acquire these cells at very low cost and do our own modules because A123 won't play. But while we're doing that, we have to keep in mind that what we wind up with that goes in a car, you have to be able to shake, rain on, and thermally cycle, not seasonally, not when you use the car, but every time you press the accelerator, you're dumping 400, 500, 600, 700 amps through one of these. Right now we're doing 50 amps, and I'm ice cold on all these surfaces. Again, the observation is that aluminum is quite good at wicking away temperature, and these thin plates with a large area are kind of just the thing for doing this. My cables actually get warm at a couple hundred amps, but my little plates don't because they're simply exposed to the air and they actually have a little heat sink action. If we can get this end plate to be the right thickness, rigidity, dielectric, and heat resistance, where it holds its shape better than the Molex connector of this, then we'll have a package that's sufficiently hardy to ride in a car. If we mind our P's and Q's making connections to it and don't wind up with all this spaghetti wiring to monitor it. I'm at 93.8 amp hours, 12.44 volts across the board. My cells look like 3.13 volts, and they're fairly even. Now here's the danger with what I'm doing in this design, and that is I have 6 tabs perfectly connected here, 5 tabs connected here, 4 here, and 6 over here. And that gives me kind of variable capacities through the cell, which can be a problem. So we have to get all those tabs into the game, and I'm finding that the best way is to make a little roll out of 2 of them that sticks up, have 3 of those on each of these, and then smash them with these little plates. Again, we're going to use Nordlock washers. These are the ones I have for 1/4-inch bolts, but we're going to the number 10s. So I've ordered some appropriately sized Nordlocks and some socket screws of a 1/2-inch length. I got 1/2 inch and 3/4. And we're going to try those in these plates. Once we get to a design that we like dimensionally, and with the plates and with the screws, and that the screws don't come loose and that it doesn't vibrate loose, we're probably going to have Lucian over at Cape Precision Machine make me a little bit more professionally dimensioned mold with the screw positions and the edges of the mold and so forth, a little bit more of a machined type situation. And it would be quite feasible to have a half mold to do a 6 volt 100 amp cell, or even a 3.3 volt 100 amp cell. And it would also be quite permissible to add another whole mold here and be at 24 volts and this wide and the same length. And so there's different things we can do with that. What are we seeing here? Well, I've got a low cell is what that's alerting me to. 2.98 volts, so that's actually okay. We're going to go down to 2.5 volts on these cells. Again, this is set up. You can set up these low voltage things, alarms, and I hadn't done that on this device. And so it becomes kind of the boy that cried wolf. We're at 12.31 volts for the 4, and we would take this down, I would say 10 volts is our cutoff. That's 2.5 volts under load, 50 amps. We ought to be able to take it down to that, shut it off, and they should recover to about 2.75 volts, and I would call that 100% discharged at 0.5 C, which is what we're doing here. So we're doing pretty well, actually. We're certainly going to get over 100 amp hours. I don't think we'll get 120, but we should certainly get over the 100 out of this battery pack. It'll nominally be 13.4 volts at 100 amp hours would be 1,340 watt hours. Some people like to do what the price is per kilowatt hour. Now we'll have 24 cells. If you can get them at 20 bucks, that would be $480 plus whatever your hardware is to make them into a module. And so that's going to probably get you to a little over $500 for a 100 amp hour 12 volt pack. Now in the Speedster, what are we running? 120 volts, so 10 of them would actually get you to 134 volts. That'd be higher voltage than we're really doing. 9 of them would actually work as 9 would get you to 90 plus 27 it would be 117 volts. That car would run fine with that. So 9 or 10 of these packs, and so you're down on your, at 10 packs, $500. You're at $5,000 worth of batteries instead of the $8,000 that we have in the car. Now you're not going to go as far, but you'll actually have more than enough power to run that little 650 volt amp Curtis to death. You're only asking 6.5 things. So we could even cut that in half and do 50 amp hour cells, and cut our cost further and still be able to drive the motor and the controller, although the car wouldn't go very far. We're at 98 amp hours, 12.23 volts, and let's just watch this till the dirty end. Okay, we're doing pretty well here. We're at 109.76 amp hours. I have a secondary counter here with a Bruce Sherry design amp hour head, and it says 110.6. We're saying 1.9.9. That's all within 1% of each other. So about 110 amp hours. I'm at 10.62 volts and falling. Let's see how we're doing over here. Well, they're all looking about 2.5, 2.6, 2.7. Badly in need of a bottom balance, but I think we're going to get there at about the same point. So we're at 10.5 volts and falling at 110 amp hours. Again, we did not get to 120, but we're well over 100. So now we're a Chinese 100, well over 100. But not and an American 120, about 110. So that'll be a good pack size. 24 cells. We're at 6P4S. 10.33 volts. .26 and falling. I don't know if you can see this voltmeter or not, but 10.20. We're at 111.15 amp hours, and so we're getting pretty good juice out of this battery at 50 amps, and so that's worked out pretty well. After we do this capacity test, we'll recharge it and go see what kind of sag we get on a, say, a 400 amp mic. And there's 10 volts. I'm going to call it at 111.5 amp hours. That's pretty much the story on the 20 amp hour cells. 111.5. Divided by 6, 18.58 amp hours per cell. And so that's about what we've been seeing. It's about 18.5, 18.6 amp hours per cell on average. But we've got us a pretty nice little module here. I need to do something more elegant than the little copper strap here. I can turn this around where you can see, but it looks just like the other end. Negative to positive, big strap across these two, and then this is our positive terminal, and that's where our positive cable goes. We're absolutely cool on all these terminals and on the cells themselves. We've got no temperature going, nothing even to measure here at 50 amps. We'll run it at 400 and see if it gets a little warmer, and after we charge her back up.
Well, it seems to be getting better.
You know,
there's
does
progress.
get better,
I know
Mark.
it is getting better.
This is I've got this kid Dan Friedrichsen, sends me advice 3 times a day. It's not what it looks like, Dan. It's not a matter of sitting around and being brilliant. Nobody sits around and bees brilliant. You can't do that. What you do is obsessively attack the same problem 325 times. You usually solve it at about 290, but you're so used to keeping doing it.
You need some extra just in case.
It's 315 before you wind down and find out.
You knew
number
that you actually got it.
was really pretty good, and it's not getting better anymore.
No,
it's getting worse.
Stop.
It's a reiterative process. It's a painful process, and by the way, it's how all of them actually do it. It's not by sitting around and being brilliant and using a lot of really slick SolidWorks. Although SolidWorks is pretty cool.
SolidWorks is pretty cool. Yeah.
But that's not, you still have to make it up, throw it on the vibration table, test it, tear it apart.
See what the heck happened.
Do it again. And that's what we're doing. We hope some of you all will do the same thing.
Yeah.
Because I think a good, if someone would come up with something brilliant on a module for the A123 cells, it could be quite useful to this community. I believe these cells are going to be available and are going to come down in price.
They are, yeah. Yep.
And so, in any event, I don't have any more for December 9th.
I think that's...
Let's save the rest for December the 16th.
Yeah, we'll save the next couple hours for December 5th, 16th.
I'm Jack Rickard for EVTV.
And I'm Brian Otto.
We'll talk to you all later.
See you next week.